Hi, Algebra 1. So we'll be giving you a new book for this quarter up through December. Um, we might just have worksheets for you guys for the first couple days until we get the actual books in. But we are going to start on these new concepts. So make sure this will be a whole bunch of videos all in one. Um, so just be aware where it starts and stops. Okay, so the first thing we're going to start exploring some patterns. So explore understanding of arithmetic sequences with explicit formula and using them to model situation, develop understanding of the common difference. Okay, so it looks like we started out with one, and then we added the corners, and then we added the corners again. So we would add at 3 minutes. I'll do this in this red. It would look like this, and then at 4 minutes, it would have this. Okay, so that's basically, the pink is at 3 minutes, the green is at 4 minutes. All right, so how many dots are there? 100 minutes. So at in the beginning, when we first started, there was one dot. And then at 1 minute in, it looks like there's 5 dots. And at 2 minutes in, count the black dots. So there's 9. At 3 minutes in, there's 13. If you count those pink dots. And then at 4 minutes in, you include the blue dots, so 17. So I want to think about what this looks like. So at 0, we had 1. At 1, we have 5. At 2, we had 9. 3, 4, 5, 6, 7, 8, 9. At 3, we had 13. So that's 9, 10, 11, 12, 13. And then at 4, we had 17. So that's 13, 14, 15, 16. Maybe it's up here. Okay, so you notice they kind of um, follow a straight line, right? So things that I want you to notice is we're adding 4 dots each time. Okay, here we're adding 1 minute. So 1 minute takes place on each of these, so on and so forth. Okay, so we want to think about how that's going to work. So what did we start with? How many dots was in the very beginning? Yeah, there was 1, so we're going to put a +1 there. Okay, so think about this. In the y direction, in the vertical direction, in this direction here, y, we're going up 1, 2, 3, 4, and we're going to the right 1. So we're going to call that an x. Okay, so we could say, hey, f at x, sometimes we could call f at x is the same thing as saying y equals. So basically our equation is y equals 4 over 1x plus 1, where this was where we started. This is what we did vertically. This is what we did in the right-left direction. Okay, a arithmetic sequence with a common difference, and that's the y, with the outputs. So the outputs are the y values. Okay, and then an explicit formula relates to a specific, I'm not quite sure what the word that we need there, but that's okay. All right, so we want you to try this. Now, I'm going to work these out, but you should try it on your own to see if you can figure it out. Use the video to guide you along. So it looks like we started with 1 dot, and then we added 3 dots, and we added 3 more dots, and then if we kept going, went that way. And then at 4 minutes, we'd add one more thing of dots. So what I'll do is I'm going to add this. That's what have taken place at 4 minutes, okay? So at 0 minutes, we had 1 dot. At 1 minute, we had 4 dots. At 2 minutes, we had 7 dots. At 3 minutes, we had 10. At 4 minutes, we had 13. So it looks like we're adding 3 each time, okay? and then we're adding 1 as we go down this way. So if we plotted these, I did right here, 0, 1, then 1, 4, and then 2, 7, 5, 6, 7, and then 3, 10, 7, 8, 9, 10, and then 4, 13, 11, 12, 13, 14. So again, see how they form a straight line? That's what we want. So we're going to call this f at x. Remember, that means the same thing as y is equal to, how many did we start with? Well, we started with 1. That's our starting point. Okay? And then in the y direction, we were adding 3 each time and adding 1 minute. So we'll put an x there. So we could actually have this equation be this as well. You know, y equals, or f at x equals. It doesn't really matter. So we're going to continue this. Step 1, and it looks like we're adding 3 each time. So for step 4, I would add over here, here, and here. And then for step 5, I would add 1 more each in these directions, these boxes. So again, so notice this says step 1. Ooh, so step 1, we're going to come down here. Ooh, that was a little different. Okay, so we don't really know what goes there. That's okay. At 2, we had 4 dots. At 3, we had 7 dots. At 4, we had 10 dots. So we don't know really what 0 is, but we're at 1, 1 right here. Now, we can sit there and see that we were adding 3 each time this time. So if we went back this way, we would subtract 3. So 1 minus 3, that would be -2. So now we do actually know that. We can't really see that, but that's down here. And then at step 2, we add 3 more. At step 3, we add 3 more. At step 4, we add 3 more. Hopefully I did that right. Okay, so again, they fall into a straight line. So we have f at x. Well, what was our starting point? It was -2. Okay, and then we're adding 3 each time in the y direction, which is f at x, and 1 each time in the x direction. So that's our equation. So we could also have changed this to look like this. All right, this is the next lesson. This is for 4.2. We just did the homework for 4.1. So make sure you know that when to stop. This might be the next day for a lesson. Okay, so this is talking about Drew is excited to add push-ups to his daily exercise routine. He's keeping track of the number of push-ups he completes each day on a given bar graph, with day 1 showing the completed push-ups, and after 4 days he believes to continue this pattern and increasing the number of push-ups he does each day. So at the very first day there was 3, and then he added 2 more, and then he added 2 more. So day 4, day 5, he added 2 more, added 2 more. Okay, so at the first day he did 3. At the second day he did 5. At the third day he did 7. At the fourth day he did 9. At the fifth day he did 11. Oops, that goes right there. Sorry about that. So again, starts from a straight line. So again, we are adding 2 each way. So if we wanted to find like what was happening at 0, we can subtract 2. So 3 minus 2 is 1. Okay, and that will be important for us when we make our equation, because we want to see where it's crossing the y-axis. So we have f at x, where it crosses the y-axis is at 1, and he increases 2 each day, so 2 over 1. So we can also have the equation look like this. That's all we do. And then this looks like it takes us down to, this is the homework. So again, if you just copy this down, you don't really know it, you might want to just use this as a guide. So describe the pattern. Well, there's 2 dots here, then we have 4, and then we have 6, 8, 10, and it just keeps going. Okay, so we're adding each 2. So the 10th term, so if we follow this out to 10, we can count it out. That's pretty easy. So we're adding 2 each time. So which basically means we could say, hey, we have this equation. We can make that f of x, but I'll just make it y. He's increasing 2 each day. And we started with, if we added 2 here, if we subtract that, we could say 0 right there. And so then, because if we went back to the 0 day, that would be 0, because we're subtracting 2 from it. So if I want the 10th day, I just plug a 10 right in here. So 2 times 10 is, there's 20 dots. Then we got this pattern, kind of looks like an S or something. I don't know. So we're taking a look at this. So it looks like we have 6 dots here, and then we have 7, 8, 9, 10, 11. So we added 5. We're going to add 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 5. So again, if we went backwards, remember we're adding 5 as we went this way. So if I went this way to the 0 term, that's going to be where across the y-axis. That's going to take me to 1. Okay, so that means our equation is going to be f of x, or y equals, plus 1, and we're increasing each time by 5, so 5 over 1x. So if we want to figure out the 10th term, 5 times 10 is 50. 50 plus 1 is 51 dots. That's kind of weird. I don't know if we can actually draw that figure with 51 dots. That's a lot of drawing. Okay, so from the table, we're starting it with 1. It looks like we have 5 dots. And then 6, 7, 8. We have 8 dots, adding 3 each time. 11 dots, 14 dots, 17 dots, 20 dots, 23 dots. We added 3. So remember, let's go back to the 0. So if we were adding 3 each way this way, I'm going to subtract 3. That's going to take me to 2. So that means my equation, we'll make it y equals this time rather than f of x. So we're increasing each time by 3 in the y, 1 in the x. And then our starting point, 0, is at 2. Okay, so the 10th term, I'm going to go plug 10 in right here. 3 times 10, or 3 over 1 is the same thing as 3. 3 times 10 is 30. 30 plus 2 is 32 dots. That's a lot of dots. I'm not going to draw 32 dots. Okay, let's take a look at our pattern. We start with 4, and then we add, looks like 3 more. Add 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 3 more. So we want to see what's at 10th dots. So again, if we're adding 3 each time in the y direction, I'm going to subtract 3 for the 0 term, so that's going to put me at 1. So I'm going to take my equation. We'll change this one back to f of x. So we're increasing each time by 3 over 1 in the x with an x, and then plus 1 because of this 1 here. So we wanted the 10th dot. So 3 over 1 is 3. 3 times 10 is 10, or 30. 30 plus 1 is 31 dots. And I'm not going to draw it. That's kind of silly. All right, here's our next question, our next lesson. So make sure you're seeing where we're doing in class. It says students will be able to analyze the key features of the function, specifically domain and range, increasing in intervals of increasing, decreasing, and constant, and as well as the x and y intercepts. Okay, so let's take a look. It says Alonzo, Maria, and Sierra were floating in their inner tubes in a river and enjoying the day. Alonzo noticed that sometimes the water was much deeper in some places than in others. Maria noticed the times that they were moving faster at other times. To learn more about the river, they collected data through the trip. Alonzo's graph pictured below, so this is Alonzo's graph, shows the depth of the water as they floated along. Next is Maria's graph that she was collecting on her GPS, providing the distance they had traveled. Okay, so if we look at this one, at 0, they're at 4 feet, and then at 30 minutes in, they are at 10 feet, and then it went back down, and then went back up. This is how deep the water was. This is how fast they were going. So, they were standing still, and then like here, they traveled 10,000 feet, and then here they traveled, more feet. So I figure it looks like they're counting by 2,000, 2,000, 4,000, 6,000, 8, so on and so forth. Okay, so we want to think about the domain on Alonzo's graph. So we're going to look at this graph first. So it starts at 0, and it goes all the way out to 120. Okay, and we're going to put those with square brackets. If you make round brackets, that's okay for right now. Our tallest value is here at 90. Looks like it's 11 feet. And where is it increasing? Well, it's increasing here So we're going to say in the x direction. So from 0 to 30, it's increasing. That's where it's increasing. So from 0 in the x to 30. And then it's also increasing from 60 all the way up to 90. And then what's the x-intercept? The x-intercept is at I don't know. It's not going to cross the x-intercept, is it? Okay, maybe this should be the y-intercept. Let's make that the y-intercept. Okay, I think that was a misprint. So it looks like 0, 4 is the y-intercept on that particular graph. Okay, the range, we're looking at the y value, so it goes from 4 all the way up to 11. The minimum value, the lowest value, looks like 4. And where is it decreasing? Well, it's decreasing from 30 minutes to 60 minutes. It's also decreasing from 90 to 120. Oh, wait. I guess this should be the x-intercept. So the y-intercept is at 0, 4. The x-intercept, it's not going to cross the x-axis, so this does not exist. I didn't read far enough into this, so it does not exist for the x-intercept. Then we're going to do the same thing with Maria's graph. So it goes from 0 all the way out to 120. Her maximum distance looks like 12, 14, 16, like about 16,000. Okay, feet, as far as the distance. Where is it increasing? The whole graph is going up, right? So it's going to be increasing from 0 all the way out to 110, 120, 120 minutes. Where's the x-intercept? It looks like it's 0, 0. That's where they started, right there. The range, we're looking at the y value, so that's going to go from 0 all the way up to 12, 14, 16, about 16,000. Our minimum is going to be 0 because it's at 0, 0. Is it decreasing? It's not decreasing at all. And then the y-intercept looks like it was also 0, 0. That was our starting point. So sometimes the x and y-intercepts can be the exact same thing. Okay, this next thing says, Sierra looked at the data collected by her 2 friends and made several of her own observations. Explain why you agree or disagree. The depth of the water increases and decreases throughout the 120-minute trip. Yeah, I'd say because, it got deep in lot. The distance traveled is always increasing. I agree. They're traveling, downriver, so they're not necessarily sitting still. The distance traveled is a function of time. I agree with that. The distance traveled is greatest in the last 10 minutes of the trip than at any other time. Okay, so let's go back and take a look at our graph. I'd say it's steepest here. That's where it's going up. So I think that one has to be false or disagree. And I disagree because it's steeper in another spot. The y-intercept of the depth of water is a function. The y-intercept of the depth of water over time is 0, 0. Well, I disagree because if we're looking at the depth, it looks like at 0 they got in and it was 4 feet deep if you go back and look at the other map. Okay. The distance traveled increases or decreases over time. Increases and decreases, or distance traveled. Well, it doesn't, I disagree. It only increases. Okay, they're floating down the river. The depth of water is never 11 feet deep. Okay, 11 feet deep. Depth of the water. How deep is the water? Yeah, it looks like, yeah, that's true. I agree with that. So I disagree. So there is, a point at 11 feet. So we'll go with that. That little tech, we'll make that feet. The range of the distance is from 0 to 15,000. Distance traveled from 0 to 15,000. Distance traveled. So 14. Yeah, this definitely, that distance is going to work. I agree with that one. I disagree. I think we went further. So if you take a look at the graph, the domain of the depth of the water with respect from 0 to 120, I disagree. That is too deep. Water's never 120 feet deep. That'd be a deep river. The range of the depth of water is from 4 to 5. I disagree because there's times that we have 11 feet for the depth. The distance time graph has no maximum value. I disagree. We get out of the river. Okay, so we didn't float and just go forever. The depth of the water reached a maximum of 30 meters. I disagree. The most we got was 11 feet for the depth. Okay. So we're going to continue our notes. Students will be able to analyze key features, functions, draw a line that matches the graph corresponding to label independent and dependent. Okay, so independent is this way, dependent is this way, okay? All right, the amount of money in a savings account where the regular deposits withdrawals are made. Okay, I think this is the one we're thinking about. The temperature of the oven on a day that mom bakes several batches of cookies. Okay, so I guess this would be it. You know, she's started the oven, opened the door, put some cookies in, went up and down. And then the amount of gasoline on hand at a gas station before a tanker truck delivers. I think it has to be this one because you're going to fill up your car, you're going to leave, and it's going to stay the same depth, and then it's going to keep going. Watermelons are delivered to a farmer's market every Saturday morning. The number of watermelons, that works. And then the amount of mileage recorded on a truck over a period of time, I'd say that's the amount of miles on a truck. The reason watermelons is this is something called discrete data as well as this, because it's you start and stop and start and stop. All right, so we're going to analyze the function. So the domain is the x values. The range are the y values. The minimum is the lowest y. The maximum is the highest y. Increasing is where it goes up and right. Decreasing, it's going down and right. Constant, it's flat. Okay, it looks like this. It doesn't change, it doesn't rise. The x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. Okay, how to write, we'll get to those. So the domain will usually either be in like parentheses or square brackets with parentheses, something like that. Same with the y value. The minimum would be at, this is just a y value. The maximum is also a y value. Increasing is x from an x starting point to an x endpoint. Decreasing is also an x starting point to an x endpoint. Constant is also x values, so start and end. The x-intercept is a number, comma 0. The y-intercept is 0 and a number. Okay, James goes on a hike. His elevation over time is shown on the graph to be identified key features. So the domain, it starts at 0 and it goes to 60. So 0 to 60. The range goes from 5 and it goes all the way to 25. Those are the y values. The minimum, the smallest value is 5. The maximum, the top value is 25. Where it's increasing is here and here. So we're going to use the x values to tell that. So it goes from 10 to 20. And then it also goes from 40 to 50. It's increasing. It's decreasing here. That's the only place. So from 30 to 40, it's decreasing. It's constant where it's like this. So from 0 to 10, and then from 20 to 30, and then from 50 to 60. The x-intercept, it does not exist. It doesn't cross this line here. The y-intercept is right there, so that's at 0, 5. That's a point. So this is the homework based off of this. So again, if you just copy this down, that doesn't mean you know it. So we're going to change some colors on this. So the domain, we're going to go from here to here. So from 0, square bracket, to 20. The range, let's change colors. The range is going to go from, this is our lowest to our highest. So from 2 to 11. The minimum is this value here. So our minimum is 2. Our maximum is 11. Where is it increasing? It's increasing here. So use the x values to say it. So from 0 to 5, it's increasing. It's decreasing here and here. So from 5 to 20. Where is the x-intercept? It does not exist. The y-intercept is at 0, 2, which is right there. Okay, again on this, for our domain, we're starting at 0, going out to 16. So 0 to 16. The range goes from 1 all the way up to 6, 7, 8. So or actually here, that's 0. So it goes from 0 all the way up to 8. The minimum looks to be 0 because that point. The maximum is this point here, which is 8. It's increasing here and here. So we're going to go from 3 to 6. And it's also increasing from 8 to 12. It's decreasing here, here, and here. So from using the x values from 0 to 3, and then from 6 to 8, and then also from 12 to 16. The x-intercept is at 0, 8. And the y-intercept does exist there. It's right there. So it's at 16. Okay, wait. I went backwards. The x-intercept is at 16, 0. The y-intercept is at 0, 8. Cool. All right, the cost of the energy level of the Tesseract over time, latest science fiction movie. Okay. All right, so the energy level, that's kind of weird. Looks like it starts at, the domain starts at about 1 and goes all the way to like 24. Our range goes from 0 all the way up to 11, 12, 13. 13 is about as high as we can see on the graph. The minimum value looks to be 0. Actually, our domain's going to be 0, right? Or it's 1. It's 1 right there. The minimum appears to be 0. The maximum appears to be 13. It's increasing here. So from 16 to 24. It's decreasing here. So that's from 1 to 16. The x-intercept looks to be at 16, 0. The y-intercept does not exist. That does not cross the y-axis. Does not exist. All right, we'll do these notes at a later day. I hope you have a great day. This should take us care of us for up to 4 days worth of lessons. Have a nice day. Take care of one another.